Hello friends, in the last two videos we have solved first 6 example from this exercise 5.3. Now we are starting example number 7. See, in this question we have to find out angle P of the triangle PQR. Coordinate of three vertices of this triangle is given to us. Means here if you will observe, one triangle is given to us, triangle PQR, and question is to find out angle P using the coordinate of these three vertices. Coordinate of PQR is given to us, but we have to find out this angle using vector method. So let us revise once again a formula to find out angle between two vector. If A bar and B bar are two vector and theta is angle between them, then this angle can be find out as cos theta is equals to A bar dot B bar upon magnitude of A bar into magnitude of B bar. This is the formula to find out angle between which two vector, A bar and B bar. Same method we are applying to find out this angle P. Means here cos P will be equals to, means we are finding what? Angle P. Here this angle theta is included in which two vector, A bar and B bar. Here this angle P is included in which two vector, PQ bar and PR bar. So instead of A bar here we will get PQ bar, and instead of B bar here we will get PR bar. So our formula will become PQ bar dot PR bar upon magnitude of PQ bar into magnitude of PR bar. Applying this formula we have to find out angle between these two vectors. Now to find out value of PQ bar, we know that PQ bar in terms of position vector can be expressed as Q bar minus P bar. In the same way, this PR bar can be expressed as what? R bar minus P bar. Means to find out the values of these two vectors, first we will require the value of position vector. Position vector of these three vertices, isn't it? So from the coordinate of these three vertices, we are able to find out the value of their position vector, means P bar, Q bar, R bar. And using position vector we will get the value of these two vectors, and once the value of these two vectors is known to us, this formula is applicable to find out angle between PQ bar and PR bar, means our required angle P. So let us define the position vector of these three vertices by P bar, Q bar, R bar. So let P bar, Q bar, R bar be the position vectors of points P, Q and R respectively. So therefore P bar will be equals to, what will the value of P bar? 0 I cap, not necessary at 0 I cap. Then what we'll get here? Minus J cap minus 2K cap. So here from the coordinate of point P we have got the value of P bar. In the same way Q bar will be equals to, from coordinate of point Q, this value will become 3I cap plus J cap plus 4K cap. And value of R bar will be equals to 5I cap plus 7J cap plus K cap. Once the value of P bar, Q bar, R bar is known to us, so this implies that PQ bar will be equals to. Now we are finding value of PQ bar. PQ bar in terms of position vector can be written as Q bar minus P bar, and PR bar in terms of position vector can be written as R bar minus P bar. Already the value of Q bar is also known to us, and value of P bar is also known to us. Simply we are taking their subtraction. Now 3I minus 0I, here term of I cap is absent, means 0I is there. 3I minus 0I will be equals to 3I cap. J minus minus means plus J. J plus J will be equals to 2J, and 4K minus minus means plus 2. 4 plus 2 will be equals to 6K cap. Now we are finding the subtraction of R bar and P bar. 5I minus 0I will be equals to 5I cap. 7J minus minus means plus J. 7J plus J will be equals to 8J cap. And lastly K minus minus means plus 2. K cap plus 2K cap will be 3K cap. Once these values are known to us, parallelly I am finding their magnitude also. So magnitude of PQ bar will be equals to, so in the denominator we will require the value of magnitude of PQ bar and PR bar. So let us try to find out magnitude. We know that if vectors are represented in Cartesian form, at that time magnitude will be equals to under root square of coefficient of I cap, means 3 square, then plus 2 square plus 6 square, which is equal to under root here 36 plus 4, 36 plus 4, 40, 40 plus 9, 49. And square root of 49 will be equals to what? 7. And here magnitude of PR bar will be equals to under root 5 square plus 8 square plus 3 square will be equals to. Now what is square of 8 will be equal to 64 and square of 3 will be equals to 9. 64 plus 9. So here we'll get 64 plus 9 plus 25. So will be equals to 18. 18 plus 5. Sorry, here square of 8 will be 64. So here 5 plus 4 is 9, 9 plus 9 is 18, carry 1, and here we will get 98. So here addition of square of these three number is equal to 98, where 98 is nothing but multiple of 49. So it can be written as 49 into 2, and 49 outside the root will become 7. So its value will be equals to 7 root 2. Once all these values are known to us, substitute all these values in this formula to find out our required angle P. So let us try to find out our required angle P here. So therefore cos P is equals to what we'll get? PQ bar dot PR bar upon magnitude of PQ bar into magnitude of PR bar. So which is equal to, in the numerator I am replacing PQ bar by its value. What is the value of PQ bar? Just we have got its value, 3I cap plus 2J cap plus 6K cap dot value of PR bar. Value of PR bar will be equals to 5I cap plus 8J cap plus 3K cap. And in the denominator substitute the value of this magnitude, where magnitude of PQ bar is 7 and magnitude of PR bar is 7 root 2. So here we will get 7 into 7 root 2. So which is equal to, let us try to find out dot product of these two vectors. If you observe these two vectors, both the vectors are in terms of what? I cap, J cap, K cap, means are in Cartesian form. At that time dot product is, first write down product of coefficient of I cap, that is 5 into 3 is 15 plus 2 into 8 is 16 plus 3 into 6 into 3 will be equals to 18. 6 3s are 18. In the denominator 7 into 7 root 2, keep it as it is. So if you observe this numerator, 15 plus 16 is 31, 31 plus 18 is 49. So here we will get 49, and in the denominator 7 sevens are 49, 49 root 2. So if we are cancelling 49 from numerator and denominator, we will get here 1 by root 2. So if the value of cos P is equals to 1 by root 2, it implies that angle P is equals to 45 degrees. Isn't it? We know that cos 45 is equal to 1 by root 2. So in this way, we have got the value of angle P of triangle PQR. So cos P is equal to 1 by root 2. So its meaning is that this angle P is equal to 45 degree, and that is our required angle here. Now let us try to solve this example number 8. In this example, it is given to us that P cap, Q cap and R cap are the unit vectors. Are the unit vectors means their magnitude will be equals to 1. Using this condition, find out the dot product of P cap dot Q cap, and second required value is dot product of P cap and R cap. Now one figure is also shown in the question. And if you observe this figure very carefully, its sides are represented by P cap, Q cap and R cap. Okay, and these three are nothing but unit vector. This is the given condition. Using this condition, now our question is to find out these two dot product. Now if you observe this figure very carefully, so here three sides are represented by this unit vector P cap, Q cap and R cap. Now since these are the unit vectors, means we can say that their magnitudes are equal, means magnitude of this will be 1 unit Magnitude of this side is also 1 unit and magnitude of this side is also 1 unit. Means we can say that length of all the three sides are equal. Means the triangle is what? Equilateral triangle. First let us try to show that triangle is equilateral, and later on we will try to find out our required values. So here it is given to us that P cap, Q cap, R cap are sides of, or are this represents sides of triangle. These three vectors represent sides of triangle. So therefore magnitude of P cap is equals to magnitude of Q cap is equal to magnitude of R cap. Better write down here, since magnitude of these three vectors are equal, so therefore we can say that triangle is equilateral. So we have proved that the triangle is equilateral since the length of all the three sides are equal. And since the triangle is equilateral, means each angle is of what? 60 degree. So therefore each angle of triangle is 60 degree. Now we have got the values of each angle of the triangle. So now we are trying to find out our first required value, that is P cap dot Q cap. So now to find out the value of this dot product, we are applying the definition of dot product. What is definition of dot product? According to our definition, first term will be magnitude of first vector into second term will be magnitude of second vector into cos theta, where theta is nothing but angle between these two vectors. But we know that this triangle is equilateral, so angle between these two vectors will be equals to 60 degrees. So which is equals to, where magnitude of P cap is 1, magnitude of Q cap is also 1, and cos 60 degree is equal to 1 by 2. Means this implies that P cap dot Q cap will be equals to 1 by 2. In this way we have got our required dot product. First required dot product of P cap and Q cap. Now we are trying to find out our second required value. So second required value is dot product of what? P cap and R cap. Again we are applying the same definition here. First term will be magnitude of first vector into magnitude of second vector into cos theta. But angle between these two vectors will be equals to what? 60 degree. So here we get 1 into 1 into 1 by 2 will be equals to 1 by 2. So this implies that dot product of P cap and R cap is also equals to 1 by 2. In this way we have got both the required values. Now let us try to solve the question number 9th. In this case we have to prove that using vector method the angle subtended on semicircle is a right angle. Already you have proved it as an one theorem that angle subtended in semicircle or angle inscribed in semicircle is what? Right angle. Or question may be asked that angle subtended by diameter of a circle at any point on the circle is what? Right angle. So let us consider, or let us denote here center of circle by O and the diameter of the circle by what? AB. Okay, and we know that this diameter divides the circle in two equal parts, and each part is called as what? Semicircle. So let us consider one point on this semicircle, denote this point say by P. So here we can say that this angle APB is inscribed in the semicircle, or we can say that this angle APB is subtended on semicircle, or we can say that this diameter AB subtend an angle APB at any point on the circle. And we have to prove that this angle is what? Right angle. This angle is right angle. So whatever may be our supposition is there, first write down all these things. So let us try to prove it. So here we are supposing that O be the center of a circle. Again, what is our supposition? AB is diameter of the circle. AB is diameter of circle, and P is any other point on circle. So therefore we can say that this angle APB is subtended on the semicircle. So angle APB is subtended on semicircle, and our aim is to show that this angle APB is equal to what? 90 degree. Means we have to show that this angle is right angle. Means we have to show that angle between this angle APB will be equals to what? 90 degree. And this result we have to prove using vector method. Angle is 90 degree means we can say that these two vectors are what? Perpendicular should be there. So means which two vector? Vector AP bar is perpendicular to what? BP bar. If we are able to prove this result that angle, these two vector AP bar and BP bar are perpendicular, means what result we will get? If these two vectors are perpendicular, means this angle will be equals to 90 degree, and that is our required result. So now to show that these two vectors are perpendicular, we have to show that their dot product will be equals to what? 0. And since we are using vector method, so first define the position vector of these points, and later on we will try to show that this dot product is 0. If dot product is 0, vector will become perpendicular, and vector become perpendicular, this angle will become what? Right angle. So how many points are there? A, B and P. We will define their position vector with respect to which point? O. So let A bar, B bar and this P bar be the position vector of point A, B and P with respect to O. So let A bar, B bar and P bar be the position vectors of points A, B and P with respect to point O. So we are defining this position vector. A bar is position vector. A bar is position vector of which point? A. With respect to what? O. Means OA bar we have denoted by A bar. In the same way, OB bar we have denoted by B bar, and OP bar we have denoted by what? P bar. Now we are trying to show that this dot product of these two vector is equal to what? Dot product will be equals to 0. Before that, if you observe this figure very carefully, here see what result we are getting. Can I say that magnitude of A bar is equal to magnitude of B bar is equal to magnitude of P bar? These are nothing but radii of same circle. Isn't it? This magnitude of A bar means OA, magnitude of B bar means OB, and magnitude of P bar means what? OP. All these are nothing but radius of the same circle. That's why we can say that magnitude means lengths are equal. So lengths can simply be denoted, magnitude of A bar can simply be denoted by A, magnitude of B bar by B, and magnitude of P bar by what? P. Let us denote it say by equation number first. Even if you observe these two vector A bar and B bar, check whether their magnitudes are equal. Yes, OA and OB are equal because are the radii of the same circle. And check that their directions are opposite. Means we can say that A bar and B bar are opposite vector, and we know that if two vectors are opposite, at that time it will be denoted by A bar is equal to minus B bar. Let us denote it by equation number 2. These two vectors have same magnitude but directions are opposite to each other. Now we are trying to find out our required dot product AP bar dot BP bar is equals to. Now this AP bar in terms of position vector can be written as what? P bar minus A bar, dot keep it as it is, and BP bar can be written as P bar minus B bar. So which is equal to, keep this P bar as it is, minus A bar also as it is, dot also as it is, P bar also as it is. This minus B bar can be replaced by what? Plus A bar. This minus B bar I am replacing by plus A bar from which equation? From equation number 2. So which is equals to, now take the dot product of these two bracket. P bar dot P bar is equal to P square. P bar dot A bar will be equals to P bar dot A bar. Now take the dot product of minus A bar with both the terms in this bracket, minus A bar dot P bar, minus A bar dot P bar, and minus into plus will become minus, and A bar dot A bar will be equals to A square. Just simply we have taken dot product of these two bracket here. So p square keep it as it is plus p bar dot a bar also as it is minus also as it is. Now a bar dot p bar can also be written as what? P bar dot a bar, because dot product is commutative. So these two terms will get cancelled. So write down the remaining term p square minus a square. So which is equal to, keep this p square as it is minus also as it is. Can I replace this a? A by what? P, because a and p are what? Equal. So I am replacing this a by p. Keep square as it is. This value we are substituting from equation number first. So p square minus p square is equal to 0. So what result we have got here? Dot product of AP bar and BP bar will be equals to 0. If dot product of two vector is 0, means it implies that AP bar is perpendicular to BP bar. And if two vectors are perpendicular, then we can say that angle between them will be equals to 90 degree. But which is the angle between AP bar and BP bar? Angle APB. So therefore angle APB is equals to 90 degree. And that is the result which we have to prove. This is nothing but angle subtended in what? Semicircle. Hence what we have proved here, angle subtended in semicircle is right angle. And this completes the proof. We have proved that angle subtended in semicircle is right angle. Now again 3 examples are given in this exercise. We will solve these 3 examples in the next video.